The visitor that stopped moving. 3 Atlas. The visitor from the dark between stars. It's currently making its way through our solar system, and every major observatory on Earth has been tracking its path with intense precision. But there's never been a precedent for what happened next, no handbook, no equation, nothing that could have predicted what this visitor would do. Because the object that would later be named 3 Atlas seemed to do something no object had ever done before. It appeared to stop moving. It was first discovered on July 1, 2025, by the surveyed telescope system known as ATLAS, a sentinel that scans the skies for new comets, asteroids, and near-Earth visitors. At first, everything about the detection looked ordinary. The data fit the classic pattern of a comet passing through our solar system, except this one came from another star. Its orbit was clearly hyperbolic, meaning it wasn't bound to the Sun. It was just passing through, a one-way traveler from the interstellar deep. Its speed was enormous. Its trajectory unmistakably alien. The data was clean, the orbit mapped, the prediction certain. But as the months passed, and 3 Atlas swept past Mars, the story began to change. Observers noticed something subtle, something no one wanted to believe. Its apparent motion began to flatten out. What should have been a smooth, predictable arc became strangely still. At first, scientists thought it was an illusion, a small error in measurement, a trick of geometry, a calibration quirk. But the telescopes checked out. The calibration was verified. The data was solid. And then, something extraordinary happened. The object's motion seemed to drop off entirely. Night after night, the position barely changed. The drift across the background stars, gone. The models broke. Predictions failed. The numbers no longer matched the sky. Emails flew between NASA, Hawaii, Chile, Europe. Each message said the same thing: this shouldn't be possible. Because 3 Atlas wasn't slowing where it should, it was approaching perihelion, nearing the Sun, where gravity should have accelerated it. Instead of speeding up, it froze. The moment when it should have been most alive, most energetic, it became still. It was as though a cosmic vehicle had coasted to a stop in mid-flight. Scientists searched for natural explanations. Maybe it was jetting. Maybe gas jets from its surface were canceling motion. Maybe outgassing balanced the gravitational pull. But none of the models fit. Nothing could reduce the expected acceleration to 0. And yet, the data refused to lie. The James Webb Space Telescope observed it too. A dense coma of carbon dioxide, traces of water vapor, and dust plumes surrounded it. But even those signs of life, of sublimating ice and jetting gas, didn't translate into motion. It was alive but unmoving. Every graph, every chart, every model, flatlined. The world's best scientists sat in silence, watching residuals that made no sense. If gravity pulls and motion accelerates, and yet nothing moves, something fundamental must be missing in our understanding. Was 3 Atlas incredibly massive? So dense that even the Sun's pull could barely move it? Or was there something else, an unknown counterforce, balancing every push and pull of physics itself? Astronomers began recalculating. The size estimates grew larger, the density higher. From a few hundred meters across to several kilometers. Some suggested a diameter of nearly 6 kilometers, a cosmic boulder drifting through the void. That would explain the inertia, but not the stillness. Because even a massive object should still move when gravity calls. As the object neared its closest point to the Sun, on October 29, 2025, the world held its breath. Everyone expected acceleration, a blazing tail, a surge of motion, a dance of light and dust. Instead, the data came in, flat. The object did not accelerate. It did not deviate. It did not obey. Charts showed angular velocity near zero. Residuals flat. Predictions lagged behind reality. 3 Atlas was, in effect, motionless, a frozen traveler where all physics said it should be flying. Scientists stared at the data and whispered the same thought. What if we're missing something entirely? Something about the composition, the structure, the origin, that changes everything we know about interstellar comets. What if 3 Atlas isn't just a comet, but a relic? A fragment of something older, colder, and stranger than we've ever seen. Because in that stillness, the universe may be trying to tell us something. That not everything that moves through the dark must move forever. The stillness of 3 Atlas didn't just puzzle astronomers, it challenged their fundamental assumptions about interstellar visitors. If an object could appear active, showing a dense coma, dust plumes, and sublimating ices, yet refuse to move as physics dictated, what else might it conceal? Perhaps the nucleus was not a typical icy comet at all, but a dense, ancient, and complex fragment, shaped by billions of years in the interstellar void. Cometary jets normally act like tiny thrusters, nudging the nucleus in response to sublimation. But here, the forces seemed to cancel each other perfectly. Gravity, outgassing, solar radiation, all balanced, leaving the object effectively motionless. Analysts revisited every assumption, its size, density, internal structure, and composition. Estimates suggested a diameter as large as 5 to 6 kilometers, massive enough that even sublimation forces would have minimal effect. Yet mass alone could not explain the extraordinary stillness. Something else, structural or dynamic, had to be in play. As it approached its closest point to the Sun, the expected acceleration, tail formation, and dramatic deviation never occurred. Instead, 3 Atlas seemed to enter a state of suspended motion, coasting almost perfectly through the solar system, defying conventional expectations. Its hyperbolic trajectory confirmed it as interstellar, but the anomaly suggested unknown influences, internal, external, or both, were subtly altering its path. Orbit models were updated mid-flight, incorporating new parameters, unmodeled forces, momentum drift anomalies, and potential structural transitions. Some scientists speculated that sublimation of deep ices might have triggered internal collapses, forming a dust crust that suppressed further outgassing. In effect, gravity and inertia dominated, while the normally active jets vanished almost entirely. This revelation reshapes our understanding of interstellar bodies. Not all are volatile-rich, highly active comets. Some may be cold, dense, and kinetically silent relics of their parent systems. Silent objects like 3 Atlas could pass through solar systems undetected, slipping past our survey thresholds because they move too little or reflect too little light. Mission planning must adapt. Trajectories, Delta-V budgets, flyby timing, all need to consider the possibility of stalling, unexpected crust formation, or sudden changes in internal structure. Even observational strategies must change. Brightness and tail formation no longer guarantee acceleration. Physical activity does not always translate into motion. 3 Atlas teaches that anomalies are opportunities, not errors. Its motionless state serves as a humbling reminder. The universe does not conform to our expectations. The object may represent a delicate balance of forces, a form of thermal or mechanical equilibrium rarely observed. Layers of refractory dust may insulate subsurface ices, while ancient radiation and micrometeorite impacts have sculpted its structure over eons. Motionlessness became a signal, a new kind of language through which the cosmos conveys hidden truths. Even in the cold, dark expanse between stars, nature can pause, hold its breath, and whisper a story of cosmic resilience and balance. 3 Atlas is not just a visitor. It is a messenger, a relic from another system, carrying the history of a distant star, the evolution of alien materials, and the lessons of interstellar survival. For scientists, it is a living laboratory, proof that even in motion, the universe can surprise, confound, and teach patience, humility, and awe.